So let's solve this question. Consider the function f of t is equal to maximum of 0 comma t whole square for minus infinity less than t less than infinity. Okay, so this is the maximum function, right? Yeah, maximum of a comma b denotes the maximum of a comma b. Fine. Which of the following statements is or are true? So function is not differentiable and its derivative is continuous. F of t is differentiable but its derivative is not continuous. F of t and its derivative are differentiable. Look, let's see solution. Then let's see here. F of t is equal to, given f of t is equal to maximum of 0 comma t, this is square, for minus infinity less than t less than infinity, correct? So first of all, let us try to resolve this function. So maximum of 0 comma t, what does this value gives you? This value is equal to, so ultimately out of 0 comma t, if t is negative and if t is positive, for example, let's see. So whenever t is less than or equal to 0, then ultimately this, out of these two, the maximum value is 0, right? Because if t is negative, maximum of 0 and a negative number is always 0. So this is 0, of course. And ultimately, if t is positive, then t is the maximum. Therefore, f of t can be written as 0 for t less than or equal to 0, then t square if t is greater than 0. This is the function. F of t is 0 if t less than or equal to 0. Then f of t is equal to t square if t greater than 0. This ultimately tells you f dash of t 0 if t less than or equal to 0, then this is 2t if t is greater than 0, of course. Okay, so t is greater than 0 means if you plot the graph, you can see the graph comes like something like this. Okay, so fine. So this is how you, this is how you have 0 till this point, and then after it's increasing as per t square. Okay, so f of t is equal to t square, and it is 0 over this part. Now clearly one thing, if you see, at t tends to 0, ultimately f dash of t is also tending to 0 from both the sides, because this is straight away anyhow 0. This, if you put t equal to 0, this is also 0. So this implies f of t is differentiable, because at every other point there is no difficulty. We have a smooth function, continuous function all over, and at every point you can define the slope. Only at this point, since the function is changing, we check the differentiability at t is equal to 0 and all other points, of course, because at all other points there is no issue. At all other points there is no issue. Now, so first of all, this function is differentiable. Okay, so it's not differentiable is wrong, of course. Then f of t is differentiable, but its derivative is not continuous. Its derivatives are actually continuous, you can see, because at t equal to 0 there is continuity between these two. At t equal to 0, this function f of t, I'll just tell you, at t is equal to 0, f dash of t is continuous. This is clearly continuous, since limit t tends to 0, f dash of t is nothing but f dash of 0, of course. This is clear. So this minus t will write slightly up. Okay, so clearly this is continuous, of course. Okay, so derivative is continuous. Yes, this statement is 100% true. This is continuous. Its derivative is not continuous is wrong, because at this particular point, see, apart from this point, at every other point the function is continuous. Okay, smooth, it has a nice structure, but here it's changing its derivative. But it's not like mod x function. Mod x has a sharp curvature and the derivative shifts drastically from -1 to 1 within a very small range. But here this is a smooth continuous signal. So therefore, whenever this time is crossing slightly 0, then ultimately the derivative is smoothly increasing. It's not like a sudden rapid increase. Okay, so therefore it is differentiable and continuous. Then what about third point? F of t and its derivatives are differentiable. No, this is not differentiable, because if you take one more derivative, f double dash of t is 0 and 2. So in the left neighborhood the derivative is 0, in the right neighborhood the derivative is 2. There is some steep change. Okay, that's why the derivative of f of t is f dash of t is not differentiable. Okay, means f of t is differentiable, but its derivatives are not differentiable actually in this case. Okay, so therefore f double dash of t does not exist, or basically you can say limit t tends to 0, f double dash of t, this does not exist. Okay, So derivative of f dash of t is not differentiable. Is not differentiable ultimately. Okay, so that's ultimately not differentiable clearly, because if you do one more differentiation, you'll get 0 and 2 here. So on the left neighborhood this is 0, on the right neighborhood it is 2, means the function, the derivative of the function increases very rapidly. So that's why it's not differentiable. The derivative of the differentiation does not exist. So this statement is also wrong because the derivatives are not differentiable. So only B is the correct answer because of these understandings and concepts. Thank you.